Hello, welcome to my channel. I am Ameya and we are discussing today about the root locus problem. So today we are going to see how we can solve root locus on graph. So the problem, we will take a g of s, h of s given k into s plus 4 upon s into s plus 2, s plus 6 and s plus 8. Okay, so the first step is to finding poles. Poles are the values which gives you the denominator 0. So for this, poles will be, number of poles will be 4, 1, 2, 3 and 4, and values of poles will be s is equal to 0, minus 2, minus 6 and minus 8. Okay, same we will do it for 0. Zeros are the numerator values which makes my equation 0. So values of s for which my numerator becomes 0. So zeros we have 1 and z is equal to minus 4 we have at the numerator. Okay, so let us calculate number of branches. Number of branches will be p or z, whichever is greater. So here it is 4 number of branches. Then number of asymptotes. Number of asymptotes will be number of pole minus 0. In this case it is 4 minus 1, which is 3. Okay, and then angle of asymptote can be given by theta is equal to 2k plus 1 into pi upon p minus z. Okay, so here we will replace k with 0, 1 and 2, and with those values you will get theta 1, which is 60 degree, theta 2, which is 180 degree, and theta 3, 300 degree. Okay, and where to draw this asymptote from? That will be the centroid. The formula for centroid is sigma is equal to summation of pole values minus summation of zero values upon p minus z. Okay, which can be given by 0, minus 2, minus 6, minus 8, minus of 4 upon p minus z is 3. So that will give you minus 4. So your asymptotes will start with the centroid at sigma is equal to minus 4. Now let us move to the graph, what we have to draw. So first thing what we have to draw is the scales. So we will be deciding two scales. So let us take first line, the vertical line, and then at the center of page you can take the horizontal line. Okay, and then you can have a markings. So this is my 0. The right hand side is my positive side, so that will be 1, 2 and 3. The left hand side is minus 1, minus 2, minus 3, minus 4, 5, 6, 7, 8, 9 and 10. On top you want a positive side, positive y, 1, 2, 3, 4, 5, 6 and 7. Same way you will go for minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. Okay, then comes your first step of marking poles and zeros. So we will mark poles with cross, and we will mark zeros with a hollow circle. Okay, so let us mark our poles first. First pole is at 0. Okay, second pole is at -2, third pole is at -6, and fourth pole is at -8. Okay, and there is one zero at s is equal to -4, so that will be a hollow circle. And at the same point you have the angles for asymptote. Okay, so then there comes the rule for root locus on real axis. So that rule is very simple. Root locus lies on real axis only when there are odd number of poles on the right hand side. Okay, so you can take first pole, count the number of poles on right hand side, there is no pole, so there will not be any root locus. You take second pole, count the number, that is 1, so there is one pole, that is an odd number, so there will be root locus on this line. So you can just make it little bit dark. Okay, then there is a 0, count the number of poles and zeros on the right hand side, that is an even number, 2 poles on the right hand side, so there will not be any root locus. For next pole, 1, 2 and 3 poles and zeros on the right hand side, so that is odd number 3, so there will be a root locus. So just highlight those things. And then there is a last pole, there will not be any root locus because 1, 2, 3, 4, so or even number will not have any root locus. And always consider one pole or 0 on this side, and then count 1, 2, 3, 4, 5, so there will be root locus on this side going towards infinity. Okay, let us talk about the branches. The branch of root locus always starts with a pole and ends with either 0 value or the infinity. So these root locus, these are both are poles, so they will go towards each other and they will break away from some point. For this branch, it will go from -6 to -4 because one is pole and one is 0, so one branch is done. So this is your one branch. For this branch, pole is going towards infinity, minus infinity, so that basically gives you the second branch. Total we have 4 branches. We have seen, we have calculated number of branches is equal to pole or 0, whichever is greater. So 2 branches will be coming from this. Okay, and those branches will follow the asymptote. So for asymptote we have calculated the centroid, which is at -4. Here pole and centroid are at basically at same point, so that's why it is coinciding. So I am just making a dashed line. So this is asymptote 1, so you can label it as theta1, which is having 60 degree. So I am measuring this angle. So for 180 it is this angle, the horizontal line, so you don't have to draw it again, you can just say theta 2 is equal to 180 degree for asymptote. And for 300 you will be measuring either complete 300 or root locus will be always symmetric about the real axis, so you can have theta 3 is equal to 300, and you can actually measure -60 from this at the bottom. So root locus should be always symmetric with the real axis, so we should follow that rule. Okay, so this is the basic drawing which you will be getting from the first steps of root locus. Okay, now what we are interested in, we are interested in this break point from which this root locus will take away from the real axis and it will go towards the imaginary axis. So for that what we need to do is we need to calculate breakaway point. Okay, and for breakaway point, what we do is we take the auxiliary equation 1 plus g of s h of s is equal to 0, and we rearrange it to get the value of k. So for this system, it will be k is equal to, I am just multiplying for the bottom, minus s raised to 4 minus 16s cube minus 76s square minus 96s upon s plus 4. Then we take dk by ds, so we derivate it with respect to s. So this is u by v rule. Okay, both the u numerator and denominator is having s terms, so we will apply u by v rule, and finally you will get s raised to 4 plus 16s cube plus 89.33s square plus 202.67s plus 67s plus 128 is equal to 0. And to find breakaway point, we need to find roots of this. Okay, so you can find these roots using a normal quadratic. Okay, but if it is difficult to find, what you can do is you can have a trial and error method. Okay, now we know that our root locus is in between these two, 0 and 2. So what we will do is we will assume s to be 0.7. Okay, we substitute s is equal to minus 0.7 and we get the value of k to be 24.6, and this should be crossing the negative value. Okay, so we assume s to be minus 0.9, we get k value to be 6.94, and we assume s to be minus 1, we get k is equal to minus 0.337. So basically my root locus is taking a breakaway point between 0.9 and 1 and 0.9. Okay, and it is very difficult to draw between 0.1 and 0.9. So for our understanding, we will just take it 0.9 as a breakaway point. Then we need to find breakaway angle. For breakaway angle, the formula is 180 upon r, where this r is number of branches approaching. Okay, so in this case it is 180 upon 2 because two branches are approaching. One branch is from -2 side, one branch is on 0 side, so it is 180 by 2, which is 90 degree. Okay, so my root locus will take away from 0.9 somewhere at this point with 90 degree, and it will go towards the asymptotes. Now the last step is about the intersection with imaginary axis. And for that you will be taking the characteristic equation, that is s raised to 4 plus 16s cube plus 76s square 96s plus ks plus k is equal to 0. So we will be deriving characteristic equation from this, and we will be using Raoult's criteria. So for Raoult's, we will quickly solve it. 176k 4k s raised to 3 will be 16, 96 plus k 0. So s square will be 1120 minus k upon 16, 4k 0, and s raised to 1 will be, let us assume it to be x, and last term s raised to 0 will be 4k. This x is basically 1120 minus k upon 16 into 96 plus k minus 64k upon 1120 minus k upon 16. So for system to be stable, we need to find the value of k for which system is stable. So we will be using this equation to find the value of k, and you will get k is equal to 327.9. So k is equal to 327.9, and above those values system is going to be stable. Okay, so for intersection what we do is we basically take this square term, okay, and make a equation. So that is 1120k minus k upon 16 s square plus 4k is equal to 0, and we substitute this highest value of k into this, so you will get s is equal to plus or minus 5.147 g. So this is what the intersection with imaginary axis is. You solve it for a Routh criteria, find the highest value of k for which system is going to be stable, and then substitute that value into the auxiliary equation of the s square row, and you get the intersection with imaginary axis. So 5.147, so 5.14 is what we are interested to plot, and 5.1 on the other side. So you just plot that, and with this you just try to draw a line which is passing through 5.1, and effectively it is going towards the imaginary axis. Okay, so breakaway point you need to mention, so you can mention it as BOP, which is breakaway point, and that breakaway point we have calculated to be 0.95. okay, so this is how you can solve a root locus for this problem, where you have 4 poles and 1 0, and we are trying to solve the complete root locus with a graph. Okay, so if you like this content, do subscribe my channel, follow for more videos on control system. Thank you for joining.